Very good evening to all. Today we are going to see how to generate a square waveform in 8051 microcontroller with on period of 100 microseconds and then off period of 600 microseconds using timer 0 in mode 1, and then we are going to use the crystal frequency is 11.0592 MHz for generating a square waveform with on period of 100 microseconds and then off period of 600 microseconds. Okay, the first of all, we know the how to configure the timer mode register. Actually, uh, in 8051 we are having two 16-bit timer is available. One is timer 0, another one is the timer 1. Timer timer 0, another one is the timer 1. So totally it will be having mode 0, mode 1, mode 2 and then mode 3. Totally 4 modes is available. Whenever we are making it's an 0 0, M0 M1 was 0 0, it's act as a mode 0. Mode 0 is a 13-bit counter. 13-bit counter means it will be counts from 4 0, that means 0 0 0 x to 1 triple f. It will be counts 13 bits. It is a 13-bit counter. Whenever we are configuring as mode 1, that means M0 is 1, M1 is 0. So what will be happen? It will be act as a mode 1. Mode 1 is a 16-bit counter. It will be counts 40 to 4f, 0 0 0 to f. Okay, and then mode 2 is an 8-bit timer. It's an auto reload mode. It's an auto reload means once we have loaded the timer value means it's automatically reloaded. Whenever that it will be overflows, it's automatically load the timer values. That's an auto reload mode. And then mode 2 is a split timer. Actually in our case we are going to use timer 0 mode 1 module. So how, let me discuss how to configure the timer 0 mode 1 configuration. The first of all, we are going to use only timer 0. So you can make it as timer 1 was everything was 0, all the modes, and then gate everything you can make it as a 0. And then in timer 0 you can make gate 0, and then C by T bar is also 0, and then M0 M1 we have to set as a 0 1. Why? Because we are setting it's in 0 1, it's in mode 1. If you are setting it's both 0, M0 M1 was 0 0 means mode 0, 1 0 means M0 is 0, and then M1 was 1 means it's called by n mode 2. So in our case we need to generate a square wave in the mode 1 timer 0. So far in timer 0 we are making 0 1 for M1 and then M0. The next step this corresponding hex value for that is this value is equal to 0, and then this value is equal to 1. So while we are configuring the T mode value, we will be make as we need to configure as 0 1. The next our crystal frequency value was 11.0592 MHz. So we have to convert it in machine cycle frequency. So we have to divide with 12. So we will get as 0.9216 MHz. So we have converted to time. So T equal to 1 by f. So 1 divided by 0.9216 MHz, we will get as 1.085 microseconds. It will be means every count it will be takes 1.085 microseconds. So our case is on period was 100 microseconds and then off period was 600 microseconds. Is it correct? So on period it's desired count. This was an on period timer on period. So on period was, what is that on period time was 100 microseconds. So 100 microseconds divided by 1.085 microseconds. So what we will get as a 92.17, that is corresponding x value was 5c. So like that in the timer off mode is 600 microseconds. Timer off mode was 600 microseconds. So far it's we have to divide 600 microseconds divided by 1.085 microseconds. We will get it's an 553. It's an corresponding hexadecimal value was 229. So this was an load count one. That means in timer we need to load the value for on condition. Maximum count minus desired count plus 1. Maximum count is 4f. That means FFF. Why? Because we are saying maximum count was FFF, means we are using timer 0 mode 1. Okay, it's mode 1 means it's a 16-bit counter. So the maximum value was 4f. FFFF minus desired count. Desired count for on is 5c. So FFF minus 5c plus 1. So that's plus 1. So we will get as FFA4 as an hexadecimal FFA4 hexadecimal value for timer 1 load count value. Like that we have to calculate, sorry, not timer 1, timer 0. Okay, like that what we have to do, we have to calculate timer off period, maximum count minus desired count plus 1. Maximum count is 4f minus desired count was 229 plus 1. So we will get as the value was FFD7. FFD7. So what are all things we have did means, initially what we have did means we have configured the timer mode. Timer mode value is, I already told with you, we are going to use timer 0 mode 1. So far we are going to configure timer 0 mode. M1 was 0, M0 is 01. It means time we are going to use timer 0 mode 1. So timer 0 mode 1. So we will configure timer mode value was 01, and then the our given crystal frequency is 11.0592 MHz. So we have to convert as a machine cycle frequency. So we will divide by 12. So we will get as the value was 0.9216 MHz. From this we have to convert as in time, t equal to 1 by f. So 0.9216 MHz, that is t equal to 1.085 microseconds. What would be means that every count it will be takes 1.085 microseconds. 1.085 microseconds. Next, we need to calculate the desired count for timer on mode. So on mode frequency, on mode duration was 100 microseconds. So we have to divide 100 microseconds divided by 1.085 microseconds. So we will get hexa value was 5c. Like that, t of timer off is 600 microseconds. It's given in question 600 microseconds. So we can divide with 1.085 microseconds. We will get the corresponding hex value is 229. So the next timer load value for on and the off we need to identify. Timer load value for on is the maximum count was of FFF minus desired count, which was we calculated for timer on mode 5c plus 1. So we will get the timer on values FFA4. What it will be means it will be counts, the starting count is FFA4 to 4f. So totally it will be takes 100 microseconds. Like that, timer off, in the timer off it will be counts from FFD7 to 4f, that means FFF. So it will be taking 600 microseconds to count this value. Okay, let me discuss the program in Proteus. Listen, the first of all what we have it means, we initially origin value we have such as 0 0 0. We are going to generate a square waveform in port 2.1. So we are mentioned, we have declared clear port 2.1. This was an output port, and then we are going to start the program. Move timer mode comma hash 01. Why we are put hash 01? Because we are going to use timer 0 mode 1. Timer 0 mode 1. So timer 0 mode 1 means it will becomes 01. So we are configured as a T mode 01. The next we will be load for first on condition. So on condition, what is the value for on condition? So on condition value is FFA4. FF is higher timer byte, and then A4 is the timer lower byte. So TH0 is th naught comma has 0 ff for higher byte value, move tl naught comma has 0 a4 is a lower byte value, so it's a lower byte value. Okay, and then the next I told with you this is for on condition, so set b port 2.1, and then we have to start timer. For start timer we will use then set b timer run bit, so it will be run until timer flag will be overflow. When the timer flag will be overflow, whenever it will be reaches the 100 microseconds, that time it will be timer flag will be overflow. The next what we are going to do means we are going to clear the timer run bit. We are going to stop the timer run bit, and then we are going to clear the timer overflow flag, and then what we are going to do means we are going to complement for port 2.1. Actually initially what we got it means for on condition we have set b port 2.1. Complement port 2.1 means what will be happen, it's automatically it will be complement value, that means clear 2.1, it means clear 2.1, it will be going to clear. Initially it will be high means now here it will be low, otherwise you can mention it's in clear port 2.1, there is no issues. The next we are going to load the timer off condition value, move th naught comma 0 fd for higher byte, move tl naught comma has 0 d7 was lower byte value. Let me check it. Here timer off condition value is for higher byte was ff and the lower byte was d7. So here ff so it will becomes ff d7. Here we have mentioned fd, it's an ff d7. ff d7, and then next what we are going to do means we are going to set b timer run bit. Okay, it will be waits until timer flag will be overflows. Whenever it will be 600 microseconds was completed, it will be overflows. The next line it will be goes clear timer run bit, and then clear timer overflow flag, and then as jump start it will be goes again the first line. Okay, let me check the output with help of the oscilloscope. So oscilloscope was taken, and then we have to connect the oscilloscope in the port 2.1. so we have to connect with port 2.1, and then we have to click simulation. Wait, listen, I have did small mistake. What is that means? Actually that 4f minus 229 plus 1. So while we have to subtract 4f minus 229 means we will get as an value as fd d7. Actually I have mentioned here ff d7, it's wrong, fd d7. So let me check it in program again. In program we have to modify fd d7, and then you have to simulate. So now we can able to see the on period was 100 microseconds, and then off period was 600 microseconds. It's the on period was that it was very small, it's in 100 microseconds. So the off period was it will be takes 600 microseconds. Okay, I hope it's easy to understand everybody. Thank you all.